Okay, question 29 in chapter 8. This brings us to kind of the time where we can put everything together and really use probabilities to come up with something that has a real world application, being things like your car insurance, gambling. Running a business, you want to know if you're going to make a profit or not. So this is the concept of expected value. The one thing you have to get in mind is that you never expect to get the expected value. The expected value is a calculation of what would happen if something was done a large number of times. We're talking millions of times. So it's not in an instant event, a single event, but in a conglomeration of events that we get the expected value. So it's a way to see, will we make a profit, will we make a loss, what's sort of going to be the costs based on probabilities. So question 29, as we've got here, we've got the marbles, but we've now turned this into a game. If you pull out a certain marble, like a gold marble, you win $3, silver you'll win $2, and if you get the black marble, you've got to pay out some money. So the way expected values work is we have to figure out the probabilities. And then we take those probabilities and multiply them by the outcome, how much we will either get paid or how much we have to pay. So I'm just going to put it over here, expected results. So first, if we get a gold, so we're going to count the probability of getting a gold. There's 3 gold, 6 silver, and 28 blacks. So that's 3 out of 3 plus 6 plus 28. Let's see, that's 9. That's going to be 37. So that's 3 out of 37. I'm just going to put the 37 up here because we'll probably be using it quite a few times. And so that one gives us a decimal amount of 0.081. That's what we're going to use to get the expected result. So if we get a gold ball, we win $3, and we multiply that times the probability. I'm going to shorten this up a little bit. The probability of getting a silver, well, there are 6 silvers out of 37, so that gives us 0.162. So you'll see the 0.162 here, and you'll see that we get $2. We multiply. Parentheses implies multiplication, but I'll put the dot there to emphasize that that's multiplication. Then the probability of getting a black ball, there's 28 of those out of 37. That gives us a decimal of 0.757. So we're going to take that, 757. We're going to multiply it by the expected result, which is we would lose $1. So this is all from our perspective, not from our friend who's going to have to pay it out. So we do the multiplication here, and we get that we would get 24 cents. Here we get 0.324, and here we get a negative number, 0.757. Okay, now the expected value is going to be the total of all of these, so we're going to add them all together. If you do that, you will find you'll get negative 0.19. We would lose 19 cents if we played this game a lot. Now again, any particular game we play, we will either get 3, we'll either win 3, we'll win 2, or we'll lose 1. We never lose 19 cents in a particular game. But the thing is this is telling us over a long period of time, we would expect to come up with a net loss of 19 cents if we took our wins and our losses happening as probability says they would happen. So probably not a good game to play. in game theory, what they do is they look at this expected value. If it's equal to 0, that's what's called a fair game, equal ways of winning or losing. When it's negative, it's in the favor of the house, and that's what most gambling games are. They have a negative expected value, so that the house or the casino will be always the winner. If you ever find one in your favor, sometimes that's when people feel that that's the opportunity for them to win. But again, it's only for a large number of times.